Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to talk about chapter 8, software testing. So far in this class, what really we have done, we went through chapter 1, introduction about software, what is software, what is software process, what is system engineering, what is software engineering, what are the difference between and what's computer science, all these kind of key term and introduction to the software engineering field. Then we went there to chapter 2 and we find out the software process models. We cover the waterfall, evolutionary, incremental, etc. and reuse, which it is those that are alternative. Probably we could choose one of them. It depends on the environment of our project. What approach we are going to fulfill the requirement of our project. Chapter 3, we talk about agile. Then we went to chapter 4 and we talk about, requirement. We try to analyze the system. We try to find out what kind of requirements. Then we talk about what's requirement, what type of requirements, functional, non-functional, domain, user requirements, system requirement, etc., etc., etc. And we found, what technique we can use, to collect our requirement. Then after we get requirement, then we went to chapter 5 to do the models. The model, which it is, an abstract view of that system. And we went through the models. We went through the structural model, static one, like context diagram. Then we did the class diagrams. Again, structural one. We went and we did the interface perspective, which it is the use case and the sequence diagram. And finally, we talk about the state transition diagram, behavioral diagram, the last type of diagrams we did in chapter 5. Chapter 6, we went there and we talk about the patterns, the architecture design. What kind of really pattern is used or we are going to use in our system. We went through many patterns like the MVC, repository, abstract machine, pipe and filter, and client server. And we found, advantage of this, disadvantage of each, where use, etc., etc., etc. In chapter 7, we went through just a design and implementation, and we talk about, one example, which it is, the weather station, the wilderness weather station, and we went through it, classes, sequence diagram, etc. Then we talk about the approaches, our approaches. We mentioned outsourcing and the reuse and what's really the advantage and disadvantage, and where really we can use the reuse, which it is really, it saves us a lot of time and money. The assumption now, we did the design, the analysis, everything is okay, specification is full, the program is written, and now we need to test the program. So software testing is defined as an activity to check whether that the requirement we have from the user is really fulfilled, to check whether the actual result match the expected result, and to ensure that the software system is error-free, defect-free. It involves many different things, which it is execution of the software component or a system component to evaluate one or more properties or one of type, of testing, which it is, we could test for, if there is any defect, if there is a good in, if there is no problem in the calculation, if the system is fast, if the system is easy to use, etc., etc., etc. Software testing also help to identify errors, gaps between, the requirement and to the actual system, the one really we have. It can be done manually or automatically, and we can't really set them as automated one. There are many different types, as we are going to talk about in this lecture and the coming two lectures in the software. Like, we have white box testing, black box testing, and so on. And then we'll see in the next two lectures, what type of testing we are going to do. What really we are going to cover, and the topics we covered in this: development testing, test-driven development, release testing, user testing, and many different type of testing and names and key term we used, and we'll find about it in this lecture, as we said, and the coming two lectures. Testing is really intending to show, as really we define it in early. To show that a program does what it's intended to do. There is no contradiction, or there is no difference between the actual requirement, the actual result, and the requirement we had from the customer. And discover program defects to find it or to make it like a defect-free or error-free before it's put into use. Before we move it program to the customer, and before really we put it in production, we could find out the problem. When you test software, you execute a program using artificial data. Of course, when we test it, we use a data we could create it. But actually, this is probably the first stage of the test. There are many different stages, many different environment we could reach an environment. We could really put the production data itself, copy it from the production database and put it in a test environment and test the program, against those data. But actually, we still, test it in a test environment. But in order to test it, to make, the environment resemble the production environment, from the size of that database. Very, very important, like the size of the database. Because sometimes when we test a program and the whole database is just a few hundred records, of course, it's not going to show that the system is fast or whatever. We have to test it through an environment very close, or it is a mirror like, the production. If the production database will have like records in million, so we have to plug in some millions of records in those tables and try to test the program against them. We check the result of the test run for errors, anomalies, or information about the program's non-functional attribute. We test it, for if there is any problem, if there is any missing, if there is any defect in it. It can reveal the presence of error, not their absence. We could find out if there are errors, but you cannot guarantee, no matter what, how many times, how many test cases you test the program, really, you cannot guarantee that it is an error-free. You cannot say that there is no error at all. There are many different problems, we had back in Detroit Diesel. Some program, it ran for years and years. And I remember their program ran for about 11, 12 years with no problem. And all of a sudden, one day, boom. What's the problem? The problem, did somebody change the program? No. Somebody did anything? No. The last time we compiled the program like 11, 12 years ago. So what happened? It's the data. The data is the more dynamic thing. The first time the data, they have problem with the data, the first time the program went to the else condition, not to the then. Like if كذا then. Usually if A greater than, always A greater than B. Today, no, it's not. We never test that one. And today we have the problem, and we never test it. That's why, so it is really tough to test for all, problems, or you have test a lot of test cases. Even your program, few hundred statement, if you put even thousands of test cases, it is tough to cover all the cyclomatic paths, all the paths in your program. Testing is a part of a more general verification and validation process, which also include static validation technique. What are the goals of the program testing? First of all, to demonstrate to the developer and the customer that the software meets its requirement. For custom software, this means that there should be at least one test for every requirement in the requirement document. We have requirement, so we have to at least one test case. For generic software, the one we could buy it, ch8, commercial of the shelf, it means that there should be tests for all of the system features, plus combination of these features that will be incorporated in the product release. Now, well, testing is testing. It doesn't matter for custom or for generic. We need to find out that the program, it's an defect-free or error-free. Second goal is to discover situation in which the behavior of the software is incorrect and desirable or does not conform to its specification. Well, it's like defect testing. Well, there is a problem. The calculation is wrong. Is concerned with rooting out undesirable system behavior such as system crashes, unwanted interaction with other systems, incorrect computation, and data corruption. All these comes under the defect testing. So, the first goal leads to validation testing. You expect the system to perform correctly using a given set of test cases that reflect the system expected use. So the validation and the defect testing. The validation that we need to validate, and we talked about the validation before. We said we test the program against the user requirement. Is really what the customer wants? That's what. And usually the validation testing, it comes under a name of which it is a user acceptance testing. This means the user will attend the testing, and then we could say, yes, that's what really I want. The second goal lead to a defect testing. The test cases are designed to expose defect from system crashes. The test cases in defect testing can be deliberately obscure and need not reflect how the system is normally used. So the test cases, we try really to break the system. We try to break it to see if there is any defect or if there is any problem with the system, and we call it defect testing. Well, validation testing, we said to demonstrate to the developer that the system customer behave and meet the requirement he asked for. A successful test shows that the system operates as intended. The defect, to discover fault or defect in the software, as we said, in the slide before, its behavior incorrect or not in conformance with its specification. Successful tests that make the system perform incorrectly and so exposes a defect in the system. So we test the system or the program in many different test cases, and that's what, the first oval at the top one, which it is the input, and then the lower or the bottom one, it is really the output, and the system in the middle. So we test it, and then we could find out what is really caused the problem. What's the input which caused that problem in order to fix the system to go over it. Well, verification versus validation. We talk about this one so many times, when we did the verification and validation and the data and the requirement. Verification, it is, when we test the program against the specification. You are a software engineer. You went there and you collect requirement from the customer, and then you wrote the specification and you give it to me as a programmer. I wrote the program, I tested against the specification you gave me. Everything is okay. So it is verified now. But when I call the customer and I show him what really the result. Well, he disagreed with that. He said, no, that's not really what I want. So it is verified, but it is not valid. So verification, are we building the product right? The software should conform to its specification. We test the program against specification. But validation, are we building the right product? So we're building the product right according to the specification, but it is not really the right product, which it is, that's what not really the customer wants. Well, V&V, verification and validation, is a set of techniques, to test the system, used to build and quantify confidence in that software. The aim of it, to establish confidence that the system is fit for purpose. Will depend on the system purpose, the user expectation, and marketing environment. We look at from software purpose. Software purpose, the level of confidence depends on how critical the software is to the organization. User expectation, user may have low expectation of certain kind of software. That's what, he could probably lose a confidence in it. Marketing environment, getting a product to market early may be more important than finding defect in that program. So the software purpose, the user expectation, and the marketing, probably they play a big role in building confidence in the system, or by bypassing some of the tests, as like the marketing environment, which it is, the problem, or what really the company wants just to put that product in the market early without looking at, the defect, without, caring about, to find out and make it like a defect-free system. Inspections and testing. In system analysis and design, we have in the implementation phase, we have many different activities: coding, inspection, testing, finalized documentation, installation, data conversion, whatever. So inspection is one activity really done in the implementation. So we inspect the software actually before even we test it. And there are many different techniques to inspect it. It's like a walkthrough. You finish your program, then you bring two or three of colleagues, and you go through your code. That's before even you write any or you test any test case. In order to make that really you follow a standard, in order to find some problems even. And we used to have a technique, we call it desk checking. You go there and you go through the logic of the program, the logic. We talk about, first of all, you go through the syntax, if there is a syntax problem, and then if there is a semantics problem. It's like you act like you are a computer and you went through the whole code. But this used to be done back in the good old days, when the computer time is really expensive and our time is not. Now it is the opposite. So we let the computer really do the dirty job for us. So we start with just a code, and we try to find out all these errors, through that testing. Software inspection concerned with analysis of the static system representation to discover problems, which it is static verification, may be supplemented by a tool-based document and the code analysis. It could be a tool, or it could be, we sit together and we go through the code itself. That's discussed in chapter 15, which you don't have to worry about it. Software testing concerned with exercising and observing product behavior, which it is dynamic verification. The system is executed with test data and its operational behavior is observed. So we observe it, we observe the outcome of that system. Well, when we look at the inspection, it's very close to review. Here we review something. We review the program, which is the last, but we review requirement specification or requirement actually at the beginning, which it is really, we call it sometimes, like in the requirement engineering process, there is a validation there. Remember, one activity of the requirement engineering process is validation, requirement validation, which it is actually inspection. We review the requirement and that one. So requirement specification. We review the software architecture, the design of UML, and the database schemas, and the program. So it is in all stages, in all phases, we have to have some review or inspection. Because in our field here, review, it has no specific space or place. We could review, as we said, the requirement through the program source code. Well, software inspection, as I said, these involve people examining the source representation with the aim of discovering anomalies and defects. We review, we inspect requirement to find if there is any missing thing or if there is a contradiction between those requirements. So we could discover anomalies and defect, that type. Inspection does not require execution of a system, so may be used before implementation. And actually all the inspection, it is done before testing the program. So the last kind of inspection is inspection for the source code, which is actually before we test it. They may be applied to any representation of the system, as we said, requirement, design, configuration data, test data, schema, program, etc., etc. They have been shown to be an effective technique for discovering program errors. So really, when we inspect, when we review requirement, we find, a requirement missing. And good thing, if we find the requirement missing, if we find the anomalies, if we find the defect, and the time we should really find it, like in the requirement collection, it will save us a lot of time and money. Well, inspection really has a lot of advantage, right? We spend some time there, but we could find out, a problem early in our phase or in our stages, of building that program, and it will save us a lot of money. If we find a missing requirement, when we review the requirements at the beginning before we analyze, design, implement, whatever, I think there are many different statistics, many surveys, tell you, the difference, between if you find the requirement and the requirement review, if you find missing requirement or whatever there, if it's going to cost you an extra hour, it will cost you an extra hour if you find it there. But if you don't find it until after implementation, there are some surveys tell you it costs you 100 hours, I think 100 times. Some surveys, they said it costs you even over 1,000 times. If you find if we have a requirement and we review it and we found, there is an extra requirement we need really to have, and that requirement, it's going to cost us just like $1. If we don't find it that time, and we found it after implementation, after we give the program to the customer, probably it will cost us, 1,000 times. Why? Because we have to go to block 1 and do requirement, then analyze, change all the models, then change the design probably, add a field to the database, do the schema, write the program, test it, etc., etc. So that's what the cost is, really very high. During testing, errors can mask, hide, or others. Some advantage, sometimes we find some problem, by looking at it. We go through the code, because during testing, probably some error, probably it will hide others. Because inspection is a static process, you do not have to be concerned with interaction between errors. You look at each error, you look at each requirement if it is separately. Incomplete version of system can be inspected without additional cost. Well, incomplete version, we could really inspect it. A piece of code, we could inspect. If a program is incomplete, then you need to develop specialized test harnesses to test the part that are available. As well as searching for program defect, an inspection can also consider broader quality attribute of the program, such as compliance with standard, portability, and maintainability. Which it is really one of these things, the walkthrough or the review is just to make that really you as a programmer really follow the standard we are talking about and the one really we have in our firm, in our company. Inspection and testing are complementary, not really opposing each other. Inspection, it helps a lot in testing. Both should be used during the V&V process. Inspection can check conformance with the specification. But not conformance with the customer real requirement. Inspection cannot check non-functional characteristics such as performance, usability, whatever, because we inspect, the source code, we find out, the syntax, if it is structure, if it is a well structure or not, if it's really follow the standard, if there are some problem with this requirement or so on. But it is tough really to inspect for performance, usability, maintainability, etc. Well, in this diagram will show, the steps it go through the testing process. In the design, we design test cases. Sometimes in the requirement, we say that this requirement, we are going to test it, We create a test cases, that one in rectangle. Then we prepare a test data. So what kind of data, what kind of parameters really we're gonna supply, and when we do that test, we get the test data. Then we run the program with the test data and we get really a result. Then we compare the result with the test cases and then we come up with a test report to see if everything is okay or not. If it is pass and everything is okay, then we move from stage to another stage in the testing process. Well, we moved on to stages of testing. There are many different stages. It starts with development testing, release testing, user testing, and those stages is the one really we're gonna start with in the next lecture. So we'll see you next lecture. Bye.